Welcome to another episode of the .NET Show. In this episode, we're going to talk about application management and health monitoring of applications. This means being able to use the services built into Windows to help your users and your customers better understand what your application is doing and maybe help fix situations before they turn critical. But before we get into that, let's check in with Erica and the news.
Hello and welcome to the MSDN News Update. I'm Erica Wiechers. Microsoft will hold its next Professional Developers Conference from September 13th to the 16th in Los Angeles, California. PDC-05 will provide developers with an early look at the next wave of platform features for Windows Longhorn, Office 12, and other technologies, and an opportunity to interact with the global developer community. Those who register now until July 15th will benefit from the early bird registration savings of $300 off the full registration price. In May, MSDN launched a new developer center devoted to the hobbyist developer. The Coding for Fun Developer Center was built by a few folks at Microsoft who consider themselves hobbyist developers on nights and weekends, with the intention of giving back to the hobbyist developer community. The site has signed up several bloggers and writers who will be contributing regular articles to the Coding for Fun columns. Check it out at msdn.microsoft.com/coding4, that's the number 4, fun. Also in May, Microsoft provided a version of the Avalon and Indigo Beta 1 RC for the general public. Indigo and Avalon are the code names for two strategic developer technologies that Microsoft plans to ship in 2006 as part of the Windows Longhorn operating system. In addition, Microsoft is making these technologies available on Windows XP and Windows Server 2003. The Indigo and Avalon Beta 1 RC enables developers to continue experimenting with early builds of these technologies, get acquainted with the development experience, and provide Microsoft with feedback. On June 1st, Microsoft announced that it is adopting industry-standard extensible markup language technology for the default file formats in the next version of Microsoft Office Editions, currently codenamed Office 12. The new file formats, called Microsoft Office Open XML formats, will become the defaults for the Office 12 versions of Microsoft Office Word, Excel, and PowerPoint, which are expected to be released in the second half of 2006. And this has been the MSDN News Update. I'm Erica Wiechers.
Welcome back. Now, your dentist tells you to floss. Your doctor tells you to have regular checkups. And your mom tells you to have your vitamins. We're going to talk about Windows management and enabling your applications to do management capabilities. And to play the role of the dentist and the doctor, we have Alex Sutton and Marty Hough. Thanks for joining us.
Thank you.
So is that kind of a similar correspondence there, taking care of your health and taking care of the health of your applications?
We're essentially the plumbing that no one wants there, but when you have a problem, it's the first place everyone looks. In the event log, is there a problem, and then what does it mean? And all too often the information is bad, it's incomplete, and the administrators don't have what they're looking for. And one of the problems that we face is we don't do a very good job telling developers what to do. How to think about instrumentation and health.
Mm-hmm. And so management is something that is important for all applications to be thinking about, and yet probably not enough time is spent thinking about it with application developers.
Yeah. And that's something that we realized a couple years ago now, actually, that we weren't spending enough time up front. And one of the reasons that we started focusing on this effort was that it had to be built into the platform. It has to be built into every application. There's only so much you can do if there's no instrumentation, to be able to make sense out of it after the fact. So
when we think about management in an application, what all does that incorporate? What all does it take and deal with, both from the developer standpoint as well as from the customer or IT pro standpoint?
From a developer standpoint, management essentially means, providing the methods that an IT pro, an administrator, an operator is going to need to be able to perform the tasks that they need to be able to deploy and operate, a given application or component. to be able to monitor its behavior and know when it's going within or without of range of the service levels that it's supposed to be providing, to provide the troubleshooting guidance that it needs, and to be able to configure that application as they want it to be.
And in other words, knowledge about what the application is, what it does, what does it mean to be healthy or not, and how to operate it. And all too common that knowledge is in someone's head or written down on 3x5 cards, or in good enterprise shops in a run books. And what we want to get towards is the applications themselves should provide the knowledge about what they are, what they do, what it means to be working or not, and then what to do about it, and try to encode that knowledge first into a schema, so we have better documentation, better guidelines, and over time automate it and really start to drive down costs. If you look at IT operations, the hardware is relatively fixed. What you can control is the people cost and really time spent managing and troubleshooting systems. I think one of the biggest opportunities for Microsoft and our partners too is driving down that cost to operate Windows and Windows applications.
Aren't we just talking about the event log though?
That's just part of it. The event log is often where people start. They look in, administrators come in every morning and look, are there any problems in my systems? They may do it by hand. If they're a bit larger, they may buy a tool like Mom to do that same thing across multiple servers. Where possible, we're providing good documentation in the event about what this means, but often you need to go look for additional events, look at performance counters, perform tests. If you think about health, there's only so much that an event can indicate. It's really just a notification that something happened. At that point, it may be too late. If you think about health in a more holistic way, you want to look at trends. Are my resources consumed? Is my transaction successful? If you think about it from a service level perspective, the application may be functioning properly, but the response time is slow, and so your users, your customers are not getting out of the app what they expect. So the events themselves are just one starting point, but you need to think about what other instrumentation you have, and then even further down the road, if there was an issue that you didn't think about up front, do you have the right tracing, the right debugging available that you can turn up the volume, if you will, and start to see more information about what's going on in the system. And it's really where a lot of people are lacking now is taking this holistic view, and just adding in some events after the fact is not enough.
Mm-hmm.
And that's actually a key thing that we've changed in thinking as we're moving on for Windows Longhorn and our server applications, is the events. We had plenty of events running around in the system. Everybody was logging events. The problem was they were being logged essentially, from a development standpoint. They weren't put into context of what the operator or what the administrator was actually looking at. It told you what was wrong. You just didn't have the context of what that meant operationally to you, what services weren't actually going to be working. They were using terms that didn't necessarily equate to what an operator would expect. They don't know what COM is necessarily. They don't know when you have a COM failure, what that really means. What they need is that context of what does it look like to them, what services can't they provide for their users, and what do they need to do, more importantly, to get back out of it.
Mm-hmm. So are we just talking about better usage of the existing event log and better usage of the existing performance monitoring API and functionality?
That's one of the key goals, is better usage of that. But it's also putting the guidance and the knowledge around it, which is a key. I mean, you can have the greatest event in the world, but you need to go through the effort to say, if I see this, what's actually going on in my application at this point? If it's happening at runtime and I'm not trying to debug this, what does the person that's doing this live in deployment actually have to be able to do to get back out of where they were? And that may mean that, you have to log the events, but you also have to provide me a method to get corrected. You have to provide me a WMI provider method or something that I can query for the additional information I need. Give me a way to reset things if they've gone awry, to set the working set to something different. There's a lot of pieces that go into it. Events and performance counters are primarily just the way that you detect that something's gone out of whack.
Mm-hmm. And from a Windows manageability point of view, I think we really fallen short on delivering what our customers need. An event has a message that may or may not describe what the problem is. We have a link on each event that goes to Microsoft.com, and in all too many cases, that link, there's nothing there, or there's nothing very useful there. We've gone and now scrubbed all of the events, looked at all of the top events that people are clicking on, and making sure that there is content there, and beefing up what we have on a TechNut. But in my mind, it's a shame that our customers have to go to a site like eventid.net, which is providing a very good service, but it's doing things that we should be doing ourselves. So in Longhorn, we're really stepping back and saying, yes, there are infrastructure issues that we need to address, but the number one job is really quality of information, and making every event actionable and meaningful. I mean, there's over 32,000 events in Windows now, so it's not necessarily a lack of events. But if you look at, what are the most important things that I need to know, and is every critical error that I'm seeing in the log tell me what's actually going on, and what to do about it. And that's really where we're starting in Longhorn, and making teams step back and think about, what are the problems that users hit? What are the most common events? What are my biggest support costs? Where are my PSS calls? And making sure that they've got the right events, the right instrumentation, the right documentation, the right knowledge to tell users, here's what you need to do. Start there, then look at the rest of your events, your performance counters, your tracing. And it's this prescriptive guidance and a way for people to think about the health of the apps. That's been one of the shortcomings now. And so the plumbing's fine and good, but it's garbage in, garbage out.
Mm-hmm. So I mean, like, if I'm an application developer, when should I be thinking about the event process and making sure I'm a monitorable application?
Well, the answer is not right before you ship.
Yes,
So.
Or worse yet, after you've shipped. It's very hard to fix your instrumentation once you've shipped. I would say that designing for operations, I mean, if you really want to design for the people that are going to be using your application, the people that are going to have to be troubleshooting it, everywhere along the way, you need to be thinking about that. You need to have the operating model of what your application looks like, not just the low-level bits, not the little components that are plugged together. You need to have that model of the people that are going to be using it in your head. Right?
And specifically, you're talking about the IT pro audience as opposed to the mom and pop at their home computer audience. Or somewhere in between the two, maybe? Or
there's actually derivatives for both. It's very similar when you start looking at what it means. Essentially, mom and pop or me at home, effectively, they become the IT pro if something doesn't work, right? That's effectively what it boils down to. And the same kind of guidance, it may be in a different language that you need to provide it for them, but they effectively are the one that's going to have to say, gee, this didn't work. What do I do to get back out of it? Most people at home are conditioned not to go into the event viewer necessarily. We want to make that experience a lot better in Longhorn, or if they do get somebody, on the phone with them to, start guiding them through the problem, we want them to be able to go to event viewer, be able to lead them through it and actually say, oh, that's the thing that's causing your problem. We'll be able to lead you through it and connect you to the right knowledge. Mm-hmm. It is geared more towards the IT pro, the operator, the admin side of things. They tend to be the ones that want to monitor mission critical stuff. Downtime's not acceptable. They want to keep that window as small as possible. But we also want to keep it, so that people can help themselves, so that they don't get stuck just looking at a dialog box they don't understand.
Yeah, I mean, I think the ultimate goal is self-healing where possible, that the system can identify the problem condition through an event, through some other trigger, and take this knowledge that's encoded in a TechNet or some sort of model that says, look for this problem, look for this, and correlate it. Where we're starting now in Longhorn is providing a framework for expressing this. How do you think about all the ways that your application could fail? What does health mean? On one hand, from completely working to completely fail to some degraded state in between. Then how do you detect those states? How do you diagnose it? How do you resolve it? And depending upon the scenario that's being used, to either directly solve the problem in case of some of the power management and networking scenarios, where we can detect that, say, standby failed, identify what driver failed, go and check on Microsoft Update if there's a new driver, and tell the user, this is what happened, this is what you need to do, instead of simply logging an event in the system. To the other extreme of a MOM management pack, where you want to in a very structured way describe what steps are being taken at each point, so the IT pro has the ability to control how much automation is done. They're not going to trust the system up front. They're just going to want to be alerted. Here's what's going on. Here's what you should do, and then over time start to automate it. So we think about this knowledge of what to do being applied simply as documentation, as some automated healing in the system, things that can be expressed through wizards, and others that can be encoded in other troubleshooters and even into MOM management packs. It all comes back to thinking about, what does health mean? What do I need to do in order to detect that problem and take action on it? And that's where it ties back to events and its instrumentation. But the instrumentation is the second step. It's not the first step.
It's important to mention, though, that even though we're pushing this hard for, Longhorn and the people working on the Windows platform and the server applications that are geared towards that, the process that we're going through with the Windows teams, with Exchange, with the other people that are building management packs to build their health model first to get there, is something that works with any application. It's not a Windows specific thing. It's not a Longhorn specific thing. We have, definitely some better technology around eventing that make more sense out of this, that we can put better metadata around the kinds of events that you have, so that we can have a better filtering and query capability. But the process that you go through works for any application, and it works for any version of our operating system.
Yeah, and I think that's the first lesson, is that, in MSDN now, we explain, here's how to raise an event, here's how to use the APIs, but we really don't have articles on when to raise events, what events should you have, what should the contents be, where to log them, when to think about what goes in the event log, what's tracing, what's debugging. And people are really just left on their own to sort it out, and the answer is all too often they either don't do it, or they give incomplete information to the users. So, as an application developer, you need to be aware of your costs. So, what does it take to support your app and make your customers happy?
I mean, it sounds like it's kind of a hard problem, because it's different from your normal application standpoint. So if here's the path I'm going down to solve the checklist of functionality my program needs to do, thinking about the management, monitoring, health sort of stuff is over here. It's a different thing. I mean, like, it's similar to adding try-catch blocks to your code. Normally I put my try-catch blocks in my code after my code fails, and I say, oh, I'll put a try-catch block there, so I'll catch it the next time, and don't know what I'll do with it, but at least I'll stop it from doing a full blow-up or something like that.
Yeah. And it is a big shift. It's been hard to get people to think, look, you have to treat management of your application. All those features have to be manageable. They have to be configurable in a known way. You have to be able to troubleshoot them when something goes wrong. That is a big shift. It's like, oh, I don't want to work on the management stuff. I want to work on my features, my new features that I have in my application. We've had pretty good response inside. People, do understand that, people are spending huge amounts of money on, managing systems that are there. One of the big reasons people don't deploy new applications is they look at the cost of what it's going to take to do that. They're spending so much just maintaining and operating what's already out there that they're afraid of change. They don't want something that's going to change their environment that they don't understand. And what we're trying to change in this wave is getting that thinking changing, providing that knowledge for people so they feel comfortable being able to do that, and say, you should actually feel better about deploying the new version of this, because we can tell you all the ways that we know it's going to fail. We can get you back out of trouble if something goes wrong. We'll give you the monitoring stuff out of the box.
Yeah, but the flip side of it is, it's not a one-time thing, and that you're only going to know so much of it when the application ships, and then once your customers use it and deploy it in very strange and unpredicted ways. New errors are
Customers
going
never
to
do
come out.
that.
Oh, no, 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 no. But really, one of the lessons that we have and that we're trying to educate first the Windows team is it's an ongoing thing. Really, the ideal case, or not the ideal case, the goal is to build a feedback loop or a community of a knowledge. And so you need to start somewhere. Test that, work with your early adopters, and then learn. So what's nice about separating out a lot of the knowledge from the code is at least the documentation part can rev at any time. A lot of the instrumentation is relatively fixed, but what that means, what to do, can be added later. So if we think about one application in the case of MOM management packs, rules can be added to management packs after a product ships. So we think about it in terms of the ubiquitous KB article. That's just another form of knowledge, most commonly about problems that were not thought about before the product shipped. And what do most of those articles say? When this condition happens, this is what it means. This is what you should do. So it's another part of the process, the knowledge that we're trying to tie back into the development teams and make the knowledge, the context of what you're doing, an ongoing thing.
Mm-hmm.
Yeah.
So is management basically just taking and bringing up an event and then responding with some piece of knowledge that assists the IT pro, whatever, to change his configuration to fix that problem?
It really depends on what the condition is that they're getting into. We've really broken this down into a very structured process where we get people thinking about the discrete elements. First we have detection, right? There's ways you can detect that you're having a problem. It could be a perf counter, it could be a WMI. Provider probe that's periodically running could be an event, could be a trace, could be almost anything, or a dialog box popping up on the screen. From there, we have to diagnose, why are you seeing this problem? And we really do encourage people to think through it as an independent step, not think, end to end, here's an event, here's what I need to do. We want people to think through, how would you diagnose what the real root cause of this thing is? What are the possible root causes if it could be caused by multiple things? And then taking it through recovery. And a key thing that we're doing with teams after recovery is we also want to verify that the service came back to where it's supposed to be. It's a critical step that people frequently, forget is, oh, did I really bring the Exchange server back into where it's supposed to be? Is it actually processing mail messages now, or did I miss a step when I, corrected one little error, but I didn't quite get it back online?
Mm-hmm. So what are we as Microsoft doing differently then, moving forward to make it easier for people to take and provide this functionality in their applications?
One of the key things we're doing in Longhorn is providing better instrumentation platform, easier to actually map that stuff out. But we're also starting to provide the guidance on how do you do proper eventing? How do you build a health model for your application? Capturing that knowledge in a standardized format in a structured way that will be leverageable by things like the next version of MOM, directly will be there. Right now, we can manually translate what we're doing into a MOM 2005 or even MOM 2000 management pack to a certain extent. But the next version will directly be based on a derivative of the schema that we're working on right now for the health model that we're doing internally. Mm-hmm. It'll also be part of the system definition model. They have a section on health. It's one of the key things that if you're going to have dynamic systems that actually know how to provide monitoring information, that schema needs to capture the same stuff. Mm-hmm. So what we're doing now is laying the groundwork for capturing that in a schema that will translate to those platforms. Mm-hmm. So that it is, a no-brainer step to basically generate a MOM management pack.
Now, you've mentioned MOM several times, but what exactly is MOM?
It's Microsoft Operations Manager. It's targeted at our medium to large business customers. It's an enterprise monitoring solution that has the ability to collect information about things going wrong and to bubble that up into a monitoring console, put alerting constructs on it, notification, a workflow of what needs to be done with it, provide the knowledge that will pop up, and automate correction potentially if you have automated scripts or methods for being able to do that. And it's a direct link from what we're doing in the health model. It really captures all the knowledge that you would need to do to build a Microsoft Operations Management pack. Mm-hmm. Of, how would I build a rule that would detect this particular thing? What would the knowledge that goes with that rule to, correct the situation look like when it shows up in the console for people that are looking at it? Do I want to actually automate the diagnosis and the recovery stuff? There's a cost to doing that. You've got to write code that'll actually go out and do that. So you have to take it on a case-by-case basis. But it provides that capability of, here's the manual steps you would go through. Is it worthwhile to actually, automate that process so that people don't have to read it and take the manual steps?
Mm-hmm. Which just means not only adding more code for being able to detect the problem, respond to the problem, but also adding code to your application to allow it to be automatable,
Right.
so that a script can be written or something like that to pull that stuff through. So we're actually talking what about could be a fair amount of work for developers to think about adding to their application. What is the value on the back end then for these developers that actually take the time to do that?
Well, the first thing, most of the code that we're talking about when we're talking about automating the recovery process, Alex kind of touched on this earlier, we don't want that encoded as much in the application. If we push that logic outside of the application and say it's external scripts, it's external tools that actually do this diagnosis, it actually gives you the flexibility that if you find a better way to diagnose it, a more rapid way to bring something back online, you can change that later. You can actually just change that script, don't have to touch your internal code, don't have to go add instrumentation necessarily. If you don't have a way to detect something, pretty much the only way you can do it is to add instrumentation in some sort of service pack or maintenance release. But if you want to do the recovery and the diagnosis side of things, you can actually do that external, and we encourage people to do that. But the benefits for developers, I mean, ultimately, providing this kind of knowledge, providing this automation in something like a MOM management pack, will build, confidence in customers when you ship something, beyond anything you could do about your new features, anything that you're doing. It's saying, look, this is what it looks like when it's operating. Here's what it looks like when it's healthy. Here's what it looks like when it's not healthy. And here's how you get it back out of things. It gives them the deployment guidance that they need, to say, here's all the events that can happen. Here's all the, performance counters that we have. Here's what we expect to be reasonable thresholds in most environments. You may have to tune them for your world, but this is what we recommend, that if you see it going above this place, that you're maybe in trouble. The benefits are just reducing that total cost of ownership for their customers. Customer satisfaction of them not having to say, why is this thing failing, and I have to call somebody and get an answer to it. We can provide that knowledge to them. It'll increase, the adoption and the deployment time faster than anything you will do in your application, any marketing, any packaging that you may do to your application. Providing that kind of stuff to say, here's how you get the thing deployed, here's how it looks when you operate it, and here's the tasks and the commands you can use to actually drive that thing in an automated fashion.
And if the developers think about cost, there's cost from their customer point of view, and what's costing them to deploy, operate, and manage that app, but it could also be their costs as well in terms of support, whether it's direct customer troubleshooting, helping people resolve problems, the ability to debug issues and find out what's really going on. And as a way, think about it as a way to differentiate your app. So if you're in a competitive selling situation, you can demonstrate that your application is easier to manage, follows a lot of the Microsoft guidelines around MOF, Microsoft Operations Framework, maybe supporting a MOM management pack. What we're seeing is it's more likely you're going to be able to make that sale and show to your customer why they should choose you over a competitor. So it's both in the enterprise sense, but then also as well your own direct costs in supporting your customers.
So then if you're not in a competitive situation, you can just kind of ignore the health monitoring thing then and not have to put it in, right?
If you like answering every support email, yes.
Yeah.
So,
or if you like a competitor to come in that has a better story in this answer, and you want to potentially lose that. If I come in and say that I can, save you $10 million a year because you're going to be faster responding to these kind of issues, because you're going to be able to monitor it and meet your SLAs, you're going to lose that, that client of your application.
I suppose the support costs are a good issue because I think probably every developer out there understands the cost of doing support. Maybe the developers don't, but their bosses understand it anyway.
Yeah.
And every single support call costs a little bit of money. And so if you can spend a little bit of time up front to take care of all of the thousands of calls that are going to come through on a particular issue, that in itself is going to take and
Yeah.
save a lot of money.
And that's really the type of tactical approach that we're starting with the Windows team. Is they're asking those same questions. Hey, you're telling us to do all of this work. How can we make it manageable? So the obvious thing is start at your biggest pain points and address the customer pain, your cost, and a little bit of that thought up front really goes a long way.
So is the Windows Teams eating its own dog food and actually adding good, strong management to the underlying platform?
Oh, yes.
Oh yeah, they definitely are. You've done a session before on the Windows Longhorn Fundamentals program. One of those fundamentals, or as we sometimes call it internally, a basic, is manageability. And we have criteria about how people need to be enabling their command line support, enabling their scripting support, providing their health model so that they can do this. For the server teams, you have to provide a MOM management pack when we ship. That's one of those things that's going to be there. So out of the box, there's a monitoring answer for the customers that want to use MOM as their solution. We're also going to provide the knowledge so that from the event viewer, you'll have it. The information will be online at TechNet, so if people are using other solutions, they can also, consume the information that we're doing that. But yeah, they're definitely being held accountable to make sure that they plug into this infrastructure. We have some standardized tools that we're using to track that and make sure people are doing that, feeding into our UA team so the knowledge is going through there and being published online. So they're definitely being held accountable to it. And we're not just sticking to Windows.
Yeah, if nothing else, then that's even a better reason for application developers to think about adding this to their application, because the users, whether they're the moms and pops of the IT pro, are going to get used to dealing with management issues within the operating system itself. And where an application is not playing by those same rules, it's going to look like the odd man out.
Yeah, I mean, when an application of mine at home fails, the first place I look is the event log. Yes, I'm a little bit biased because I work on it, but I'm just like I'm trained, because if something's wrong with Windows, that's where I look, and I'm actually very disappointed that very few of my desktop apps actually raise events, particularly when it's a problem that I could go and fix, whether it's a driver, a dependency, a configuration problem. They don't let me know what's going on.
I mean, heck, I think the only time I've ever written code that writes out to the event viewer is when I was trying to test the event viewer to find out how it does things. And other than that, I don't even pay attention to it.
Yeah. A lot of people have been trained not to do that. The information that was logged historically was, from developers for developers, and the IT pros were the people that were trying to make sense out of what was being logged there. It just wasn't being geared towards their needs. And I think you'll see a shocking difference in what it looks like in Longhorn. The Windows components will look very different. They will have that health model context around all of their events. That metadata that we're capturing from the health models from these people will be there. It will be pivoting. It will be filtering it in the event viewer, so people can get at the information they need and care about quickly.
Yeah. Then the other side is as well. There are significant limitations in the existing of event log. That code really hasn't been touched since NT 351, which is why we've seen people turn towards private logs, text logs, event tracing to work around a number of the problems around schematization and performance. So our other goal in Longhorn is rewriting the event logs, the event log service to address a lot of these core issues. Make it so you don't have to go to an alternative solution and get all of the information in one place, so it's easier to understand and figure out what's going on in the system.
Yeah. A huge amount of time actually is wasted now with private log files. When something goes wrong with an application, somebody's got a text file, log file, whatever, it's in their own proprietary format. The time spent finding the logs, understanding what the heck they say versus having them in one place where I can go consume all this, it's a huge time saver for people to just go to one place and say, I'm going to go to the event viewer. I'll see the trace stuff. I'll see the normal admin and operational events. I'll see stuff if people have created a private event log now. I can actually do that and put a channel and say, my Active Directory stuff will all go over here, but it's still in one console that I can go find it and relate it to the other stuff that's going on.
And I suppose the fact that application developers are actually taking the time to do their own event logging sort of infrastructure means that they weren't finding something they needed out of the one that we are providing for them.
Some of them, as Alex said, there were some scalability things with previous versions. There were things that people just, didn't want to do with the event log. If they're doing a lot of, debug style tracing that's logging. That's not something you want an operator to see. The last thing you want to see is a transaction log firing in the event log that, every 5 seconds there's this thing showing up there. That doesn't help anybody. There are things that do that. But a lot of those things migrated to a private log structure, but that meant that they were proprietary. There was no standard tools for consuming them. And what we've done in Longhorn is we've brought those two worlds together. So I can get the best of the event viewer, and I can still link directly into those kind of trace logs and get it to one place.
So some of my developers in the audience wanted to find out more about, what we're doing with the health monitoring and the event logging and stuff like that moving forward for Longhorn, how to incorporate in that application. What are some of the best resources for them to take and rely upon and check out for getting that information?
At a high level, for the first entry point, on Microsoft.com, Windows Server System DSI, there's a white paper up there around the fundamental concepts of what we're doing in DSI, what we're looking at for the different kind of models.
And DSI stands for?
Dynamic Systems Initiative.
Okay.
It's basically building manageable applications that know how to respond in an operational environment and capturing the knowledge around those applications. There's also the health model white paper, actually, of how we're going about this, how we're thinking about the process. There's an early version of the XML schema that we were using, actually, for capturing this stuff. And so that's a good entry point up there. Linked off of there is also the stuff on the new eventing stuff into Longhorn. You can also get to it from there. I don't know if there's a more specific site that you'd point people at for the new eventing stuff.
Right, the
online.
new event infrastructure will be on MSDN for Longhorn Beta 1. There's some information out from the last PDC, but Beta 1 MSDN is the place to go.
Okay. And are you guys planning on doing a presentation at this year's PDC about the event model and health monitoring?
Yes, we're looking at a couple of sessions around manageability overall, drilling into the new eventing API, the instrumentation API, so you can also learn about the changes in perfmon and some of the diagnostic infrastructure in Windows as well. So we should have a number of very good sessions there.
Okay, yep, that sounds good. Okay, well, hopefully that gave you some insights on why you should be thinking about health monitoring your application, utilizing the event logging, utilizing performance monitoring, as well as some of the other features we're adding into the Windows-based operating system to make it easier for your developers, for your users, to find out more about what your application is doing. Following the short break, we're going to take a look at some of the programming capabilities and actually see the event modeling in action. Thanks for joining us.
You dropped this back in Black Mesa. Good luck out there, buddy. Gonna need it.
Welcome back. Now, previously we showed you what the event logging model was all about, how your application should be thinking about using it, and what the IT pros and customers that are using your applications might be thinking about when they need to access the events your application is surfacing up. In this segment, we're going to focus on what the event modeling looks like, both visually on the screen from the event viewer standpoint, as well as how applications actually add code to themselves to expose themselves. Now, joining me again, we have Alex Sutton and Marty Hough to take and show us the event logging from a programmer standpoint. Thanks for joining us back.
Okay.
So one thing we didn't mention really that much in the previous segment was on the future of event logging, which I guess you guys have codenamed Crimson,
Yes.
which is how Longhorn is going to be exposing the capabilities of eventing and profiling, and essentially the way an application talks to the system and exposes the concept of how healthy or unhealthy it is at any particular time. How exactly are we evolving that model forward to make it easier for applications to interact with the operating system in that fashion?
Okay. The first thing that we are doing is unifying the existing event APIs in a Windows. The original event log API dates back to Windows NT. It's a fairly simple API for publishing events. There are a number of system properties raised by the system, like a time. An application can specify a message that gets displayed by the users and pass in strings that can be inserted into those into that message and displayed at a runtime. The events logs themselves are memory map files. There's a very hard limit on how large those logs can be. There's certain performance limitations and how quickly those events can be raised. Because of these limitations in schema, in performance, and concerns about spamming the log and filling the log with debug events or informational events, over the years we've seen developers adopt different strategies and move away from the event log. One is a simple text file, maybe a printf, or just a simple dump of what was going on. In one sense, easy to parse. On the other hand, it's lacking a schema, and more importantly, from an administrator point of view, they don't know where to look. There's a real problem about what logs exist on Windows today and what do they mean.
I know my strategy often dealing with event logs is just to delete them because they take up too much space on my hard drive sometimes.
Yeah, but when it comes down to it, and you're actually trying to troubleshoot a problem, the information you need isn't there. And that actually speaks to one of the other downsides of managing your own logs. Are you going to control how large they get, roll them over at a certain size, roll them over at a certain date? That's one of the nice things that the event log provides. Mm-hmm. On the other extreme, we actually saw teams in Windows and create a whole new eventing API, ETW, or event tracing for Windows, really geared more. It came out of the kernel team, targeted at kernel groups, driver developers, really thinking about high volume events that are targeted more towards developers or analysis tools. But what we've heard from both customers and our own product support is they're having to use all three of these logs. And troubleshooting one problem, they're having to look in the event log, then it points them to private logs. Maybe they'll turn on tracing. This is even separate from debug logs. So the first thing we're trying to do in Longhorn is unify the eventing API and address a lot of the issues both from the developer point of view and the administrator point of view, and gain the benefits that we see in terms of performance and schematization from the event tracing with the understandability and ubiquity of the event log. So from a developer point of view, the message is just raise an event. You shouldn't have to think about, well, in this case, I use this API. In this case, I use the other. What's nice about Longhorn is just one API for raising the event, separate in the manifest that describes the events that you're raising. You can pipe that event to a particular log. And our guidance there is to think about 4 types of events. admin events, operational events, analytic events, and debug events. Each type of event has some different characteristics around how that event is used and the quality of service, if you will. The admin events are the critical events. These are the things that the administrators or users need to know when something's wrong, and they need to take action. Yes, in the ideal case, a troubleshooting script or MOM management pack can take care of that. But when an administrator wants to know if something's wrong and what to do, they want to look for those admin events. The key there is making them actionable, no noise. The next level down are operational events. These are additional events that may be useful for troubleshooting. They can indicate that an application has returned to a healthy state, or they're events that are useful for triggering automated actions. One of the new features we have in a Longhorn is the ability for the task scheduler to run an action on an event. So if you want a troubleshooting script or an email sent when a particular event happens, that can now be raised, and that event may or may not indicate a problem, so it could be an operational event. Mm-hmm. So that's actually one of the most asked for features in a Longhorn. So I'm sort of selling it short in the context of the other thing, but it's a very, very cool thing. So the admin events and the operational events are what we traditionally think of as event logs. These are always on. They're always enabled, and they're the primary logs that an administrator or tool can interact with. When we talk more about the event log in depth, these are also the logs that you can query and subscribe to. The next level down, or analytic events, are ones that are geared more towards in-depth troubleshooting, generally by tools. On the server side, there's something called the server performance advisor that in the first version helps you tune Active Directory and IIS, and they do it by enabling tracing for a period of time, seeing how the server is working, turning off the tracing, then analyzing these very large multiple gigabyte files. So they're not engaged, they're not enabled all of the time. They're not necessarily for humans to parse through, but when troubleshooting a problem, you may want to turn them on and get a deeper view of what's happening in the system. Then the fourth type of events are debug events. These are for developers, targeted for developers by developers, and they're not for end users. When you think about schema and how events may change, the debug events are for you to do whatever you want. The schema can change from release to release. On the opposite extreme are the admin events. If someone is building knowledge, whether it's a management pack, an operations run guide about what to do when managing this app, they want to make sure that the event IDs are consistent from version to version.
So the admin events are actually more of a scripted model, where the debug events are more of the proprietary model.
Yeah, I don't know if I'd call it proprietary.
Well, I mean, like, they can be anything you want, and so
yeah,
right.
If you think about schema, they're designed for you. If you think about the admin events, there's a message, and that message is describing what happened. This service stopped. This fault code was received. This is the problem that was encountered.
Right.
So so that's starting at the guidance point. Where this leads us to in Longhorn is schematization. The event log today is flat. They're the fixed system properties and number of insertion strings. People who develop scripts in MOM management packs can access those strings, but as parameter 1, parameter 2, and you have to go in advance and discover, well, this is the user here in this event, and the third parameter is the IP address. Moreover, there's no way to discover what events Windows has. It's a question that I get asked at least once a month from customers. Just tell me what error events does Windows have? Yes, we have a site on TechNet now that allows you to search those errors, but there's no report that we give of what does Windows have. So the first thing we're doing in Longhorn, after of course the event quality, is a discoverability and schema. What logs does Windows have? What events are in those logs? And what are the properties of those events?
Mm-hmm.
So leveraging the concept of a manifest, there's an XML schema for describing the events that your application raises, who the event publisher is, what logs you're going to support, whether it's a system log or a custom log, the events that you want to raise, the properties of each of those events, and those can either be string types, or in Longhorn any number of rich types, and then the message table for the localized strings that go with those events. This is the evolution of the MC files that event log users create now, which is it's a very simple text file, but again, no structure, no types around the parameters, and no definition of other parameters themselves.
Mm-hmm.
From a development point of view, it's very much the same. Instead of an MC file, you create this XML manifest file as part of your build, create the resource file with the MCXE, the message compiler, and then create the resource files that get used at a runtime. At setup time, instead of registering your resource files directly in the registry, there's a new configuration API for the event log, where you register your publisher and point us to those resource files.
In the event of the aspect of this is this actually allows the application events to be more readable by customers as well as by applications that need to have access to them, rather than the current model now where people just have to grovel through a bunch of data files that they have no idea what they're doing.
Yeah, I mean, if we think about how people interact with event logs, they're basically parsing messages, and many tools are actually looking at the message strings. Through the health model, we're trying to make the messages of themselves more useful, more meaningful. But the old event log is not understandable by tools, both the events of themselves as well as the logs. There's no ability to query. There's no ability to subscribe and get a notification when a new event was raised. It was really designed 15 years ago when one person was managing a single machine and just fairly small log files.
Mm-hmm. So let's take a look at what it actually looks like in practice.
Okay. What we have here is a recent pre-beta 1 build of Longhorn showing the new event viewer. This is a managed code snap-in being built in MMC 3.0, which used to be known as MMC 2.1. You can see the tree along the left where we have the log files, the usual or familiar application security and system logs. We now show you all of the other private logs raised by Windows components. Instead of having to grovel the system for text logs, these logs are described in their manifest and registered. Down here we have views. In the middle is the results pane with the familiar list of events, and finally an Outlook style preview pane. So instead of having to pop up a separate dialog box to see the details of an event, it's very easy to just click and scroll through the logs. And then the task pane on the right. Making it easier to filter events when the common questions or common issues is, all I care about are the error events, and here I'm seeing, a screen full of information events. We can go and very easily filter this. See, okay, I only want to see the critical and error events. So here I've now scoped my log from the 637 events overall down to just 80 84. I go down further and say I just want to see, I'm having a problem with NTFS, so let me go and look for the NTFS events. And where did they go? I'm still working on the consistent naming. One of the to-do items for beta 2, and now I've scoped it down to 14. But what you don't, while this is very, very nice, you don't want to have to do this in every single log in your system. So the other thing that we have is the ability to query across logs and say, okay, I'm interested in monitoring the system in application logs. Show me every error event in those systems.
But you can also filter based on, keywords that are common across those things. So it's not just the old style event sources or critical or warning or other things like that. You can actually say if it's a configuration related event across all the logs in the system, you can actually query for that too. So similar to what you can do, you've got a security log now. If something is tagged, even if it's not in the security log as security, we can actually bring that into one view.
And where's it picking that up at? Is it from a text string on the inside of it?
That's actually part of the metadata that ends up in the manifest that gets registered.
Yep,
with
let's
the
come back
resource.
to that in a moment.
Yep.
So let's create a view. So a view is a query that you want to save. So here I say I want to look for all the critical and error events in the system log, go to the global logs, and the application log. So here I'm able to do this query across both of the files. Underneath the covers, the queries are being processed by the Crimson or event log service, and what we support is a subset of XPath for querying these now XML events. So in the viewer, there's a way to create a simple query as well as see the XML that you can then cut and paste into your own script or code. So let's go and run this query now. We'll save it to call it.
So then by cutting and pasting that, allow an application to not have to interact with the event viewer directly, but actually just do XPath queries against existing XML data strings, which are the event logs.
Yes.
You can be a direct consumer of the
Right.
events
Wow.
that they're interested
Yeah.
in.
That's really powerful.
And you don't have to learn XPath if you
Yeah.
don't want to.
That's even more powerful.
So here's the view that we just saved. That's the error event. Instead of just 81 events, here I have 411 events that are going against both of the logs. So I can see a mix of events in the application and system logs. Here you can see just the preview pane where I'm seeing the event message. I click on the details tab. What you're going to see now is the XML view of this event. So this is what you have. This is what you have access to programmatically. At the top, we see the system properties that are raised with every event, and then underneath are the event-specific properties. These are the insertion strings. Here we can see it's just event data and data. This is that ugly GUID that was part of the event message. So we can click on another event and maybe see something a little bit more interesting. Here's actually one of our sample events. And we can see here we have two properties. Click on another event. Actually see a lot more of this is one that's being raised with the long-run API. So we're seeing some of the additional metadata that you can set in terms of opcodes, which can reflect where in the code this problem was being raised, the ability to define keywords. Is this a security event, a configuration related event?
Or a 3602879701896 event, right?
Yes. Obviously, the substitution is not being done right now. This is an interesting thing, the correlation activity. This is part of an effort that we call end-to-end tracing, and the ability to follow events across components and machines in a distributed app. So it started in conjunction with the IIS, ASP, and SQL teams. And one of the neat features about the new API is ability to set the correlation ID when you're raising events, and then pass that on to to the other components in the transaction, start to follow flows of events when troubleshooting. We're also adding in the process and thread ID that raised the event. Here we can see that we're starting to name the events, in this case, first parameter and string value. Okay.
And as well as debugging the event correlation stuff, it actually enables now, end-to-end transaction timing. If you are having an application that is bottlenecking at a certain place, you actually now can trace a particular transaction and find out where it is, getting stuck on a particular machine or in a particular service. So it enables some scenarios that we just could not do before with any overlogging or tracing that was just built in.
Okay, so a couple of the other features that we support, in addition to viewing the event logs, we've got the ability to view private event logs raised by applications, as well as the tracing and debug logs. Viewing those logs are not supported in beta 1 though. Let me show you one more thing, which is how easy it is to trigger a task on an event. Say that I want to have an email sent every time this event 110 is raised. I can simply right-click on the event or choose the attached task to this event task. This is going to bring up property pages from task scheduler. I can now specify when this event is run this action. And beta 1 is just the ability to run a program. In beta 2, it'll be the whole set of task schedule actions: raise an event, or send a mail, raise an event, start a service, etc. So here I can go and run Notepad, or actually we'll just use my send mail VBS. Now what this has done is it's gone and created a task in task scheduler. If I go to the task scheduler UI, this on-event task will be showing up there. On the event views, this is a very powerful tool for managing this large number of events and logs. Previous to Longhorn, there are only three event logs and this whole host of other logs. Now we're going out and exposing all of these other logs. It can be a bit overwhelming. So we provide the ability both for administrators to find their own views or queries, as well as shipping a number of predefined views in the box. And simple ones like this: show me every critical and error event, and then for each of the server roles, for example, file server or a web server, they're each being asked to provide at least two views: a health view and a troubleshooting view. On the health side, what events should you be looking for to understand if this role is healthy or not? And then when something goes wrong, what logs to be looking for that service or any of its dependencies. Again, taking this knowledge that's in the health model and exposing it out to your users through the tools. So now this schema and API that I've talked about so far is for new applications in Longhorn that are writing to this new API, and we realize that there's a whole world of existing apps, both raise events now and need to run on multiple versions of Windows. So the first thing is we're fully backwards compatible in terms of apps using the existing report events still work, and the event logs can be queried or read with the existing APIs. You'll still see all of the events, but be limited to the existing system properties, and the messages and parameters are the way they are today. But we really wanted to bring some of the schematization and make it available to existing apps. It's also being pragmatic in the Windows world, where most teams don't have the time to rewrite all of their events and move to a new API just because we want them to. And so while you can take an existing app using report event, your existing MC files still work. You can move completely over to the new unified API in Longhorn and create a manifest. There is a middle ground as well. By going this incremental step of writing a manifest for your events, actually describing the events that your applications raise, and registering that at runtime, you can get most of the benefits of schematization and a discovery.
To make sense, it's basically a helper file that allows the eventing system to kind of map the XML model on top of the plain text file model that the old event log was using.
Yes, what it's providing is the discoverability of what events you have and what the parameter values are. In order to make this easier, we will be providing in the SDK an MC to manifest conversion tool that will take the existing MC file, give you the structure of the manifest. You then need to just go in, name your parameters, and change your build script to look at the XML file instead of the MC file. And let me show you what this will look like from the user point of view. Then I can show you what one of these MC files actually looks like. Let's go back to the application log, and I raised a couple of events earlier. So actually, let's just be safe and let's raise them again. So I created a sample application that's going to raise three events. One, an event using the classic report event in an MC file, report event, and a manifest, and then the new Longhorn unified API. So let me just go and raise those events. Let's look in the log, and they should be there. Okay. So here is the first event comes from an MC file with two parameters. We can click down here in the details. We see that it's just a data parameter 1, parameter 2. Here's my second event where I simply converted that MC file to a manifest. I didn't have to change the code. That's why that wasn't working. Now I can see that it's a migrated event, and I declared string value 1 and string value 2, and I can add whatever name I want on those events. But I chose string value because that is the only values that we support for legacy events are string values. Now the same event was raised on a Longhorn, coming from a manifest, the same parameters. Let's just go and clean this up. And we see we have value 1, string value 1, and numeric value 2. So from an event consumption point of view, instead of having to know I have two parameters, this one is first, this one is second, I can actually name them and then reference those in my queries in an XPath query being done in the viewer, or in a query being done programmatically. So just taking a look at what this looks like in the back, from the developer point of view. Here is the MC file that we started with, event number 100. That's on error event, and this is the message file, where I can see there's insertions for parameter 1 and parameter 2. There's no way to know what those parameters are, what they mean, what their type is. It's just number 1, number 2 in my code. I then have to know to raise them in order, and then when I receive it back from the event log API, we do the substitution when rendering the message. Or if you're writing, say, a management pack, you know that you're always going to look for the second value when writing your script in order to know what the problem really is. So then what we did is we took this MC file, ran it through our conversion tool, and created manifest. So yes, it's a lot of XML, but through the tools now and what we're planning for Orcus, it's going to be a lot easier to create these events with the development tools.
And part of the difference also is that XML really isn't meant to be interacted with directly by developers or users. It's actually made so it can be consumed by another smart client application that just makes it that much prettier to edit. Where the other file would have been a lot more difficult for someone to write a parser to parse the MC file, where this is quite easily parsed.
Oh yeah, the MC parser is
As you can see,
quite interesting.
there is no schema.
Right.
Yeah.
So what we have down here is a provider that's registering the events. This is equivalent to the source today. Here in the channel section is where you define the logs that you want to raise your events to, either importing one of the global logs, the system or application log, or creating one of your own. Tasks are some of the metadata for describing these events. One of the tasks is the category for the existing events. Templates is where I describe the properties being raised by my events. Here is the migrated event, where I have parameter 1 and parameter 2. They're just string values. And then in the case of raising it for a Longhorn event, I can actually define the types for them that can then be discovered by tools that are going and managing these logs. And again, a more intelligent way of processing the events programmatically. Down in the events section is where I declare the events themselves and provide references to the metadata, the categories, or the structure or bodies of the events that can be shared across events. So what's nice about the templates section is you can define a common body, a common structure for a group of events that can be raised, that can then be shared and raised for a variety of conditions. And what we're seeing is that people don't create one template per event. What a lot of Windows teams are doing is defining one or two, and yes, it may be fairly sparse in some of the event, but really what they're driving towards are standard data that should be raised by their components when a problem is encountered. One of the teams that's really taking advantage of this is CAPI and the security certificate management APIs, and providing very rich data around the certificates, the authorities, and what's going on. Only a couple of those properties are ever exposed in the event message out to the administrator, but when they go and access these events programmatically, particularly when looking with product support, they're able to write much more intelligent scripts.
Mm-hmm.
And then down at the bottom are the string tables for the messages that get displayed in the viewer.
Mm-hmm. So basically, this all seems to make it that much easier then for both applications to interact with the information, providing the assistance that the end user is going to need for understanding the events that are being raised, and hopefully then be able to mitigate the problems involved that caused the event to be raised to begin with. And then by having the operating system allow events to actually have actions assigned to them, whether it's sending email or launching Notepad or doing things in Excel, we can actually have some automation associated with correcting or at least alerting the fact that these events are going on, rather than right now they just kind of happen in a black hole sometimes, and the IT operators have to go into the system and constantly monitor what's happening in the event log to take care of things.
Yeah, the events the events themselves are not the end goal. Just raising the events to the log is not what you want to do, and that's why you start first thinking about what events are important, making sure that they've got the right data, the right schema. Then in a Longhorn, the infrastructure improvements make it easier for these automated tools, these automated actions to happen. So the step after the schematization is support for queries. It's sort of unbelievable that the existing log is read-only. There's no way to query the log and say, show me all of the error events or show me all of the events for this. So the next really big thing that we do in Longhorn is support for queries. So instead of having to manually scroll down the log, or in the case of the WMI provider or MOM, what tools like MOM have to do is read every event in the log just to find the rule that's important for a particular management pack. And then this exercise is having to be repeated by every developer that's parsing the log. So in addition to interactive querying, we also support subscriptions. So instead of having to pull the log, today you can get a notification that a new event has been written to the log. Not necessarily one that you're interested in, but just a new event. Then you have to go and query the log, say, show me every new event since the last time, and manually then go and look, is this an event that I'm interested in? So again, what we're trying, one of the big advances in Longhorn and driving better manageability tools, making Windows itself more manageable, is first the quality of information, and then fixing the infrastructure, the plumbing in Windows, if you will, to take advantage of this new schema that we're asking people to do. So you can query, you can subscribe, and then you can actually forward events from machine to machine. On one hand, we're playing catch up with syslog in the Unix role, but on the other hand, through schema, we're really going the next level and making the events themselves much more understandable and actionable by tools.
So from a migration standpoint, since we're talking about here is stuff that isn't currently available in Windows XP and will be available in Longhorn, how soon will developers actually be able to get their hands on this model and be able to program against it?
Okay, so the recommendation for developers now is if you have an application that needs to run on Longhorn and another Windows OS, continue to raise your events with existing report event API or the managed API. In Whidbey, we make it possible to raise a message with the event and take advantage of MC files. Then in Longhorn, when you're ready to ship your app on Longhorn, convert your MC file to a manifest using our conversion tool. The resource files that you generate at build time will work both on Longhorn and on existing OSs. And then the only incremental change on Longhorn is change your setup logic to register register your events with the event system through the configuration API instead of directly in the registry.
Now, do we have specific data available today to help people understand what this new model is going to look like?
This will all be documented in the SDK for Longhorn Beta 1. I don't believe it's up on MSD. It won't be up on MSDN until later in the summer when Beta 1 ships.
Plus, also, you'll be covering this in your PDC sessions that you're doing in September.
Yes.
Okay.
So it's a very important story that your existing investments and events and instrumentation still work. We think we have a fairly small incremental step for Longhorn to make it better. There's no change required to the actual code raising the events to take advantage of the manifest. It's really a build level change and then the setup change for Longhorn.
Okay. Well, I mean, to me, it sounds like it's a very good move forward. I mean, I remember when the event log API first came into NT 3.5.1 and how exciting it was to be able to actually do that sort of stuff. But then, for me, the excitement soon waned after that, seeing how difficult it was to do it and how useful it was. But this actually seems like something that actually could see a lot of use and see a lot of added value that the IT pro as well as the customers are going to get out of the event logging model and just health monitoring overall.
That's the idea. Make it easier to raise an event and easier to manage the system, and making your applications more manageable should be easier on Windows.
Great. Well, thanks for joining us, and I'm sure our audience got a good information about how they can take and why they should start flossing after every meal and get that health monitoring stuck inside their application. Well, thanks for joining us. Hopefully that gave you some insight in how health monitoring in your application is something that's going to be important for you to do. whether it's raising events, whether it's adding profile information, or just taking and making sure that you're providing your users with the information that they need to make your applications run that much better within their environments. Thanks for joining us.
With me today is Suze Wolf. She is Director of Emerging Market Strategies. Suze, welcome.
Thank you very much.
So why don't you start by telling us what Emerging Market Strategies means exactly?
Well, it's a cross-company orchestration effort. The company is thinking about emerging markets in new ways for the first time. And there are a lot of different groups with pieces of the puzzle and only small bits trying to tie them together right now.
So how would you define an emerging market, or how does Microsoft think of an emerging market exactly?
Well, we have our own taxonomy based on where we think the greatest growth and strategic potential is. The United Nations, I believe it is, uses the figure of $9,000 US dollars per capita as the cutoff point, above which something would be a developed market. But there have been a number of different definitions. Our taxonomy and our highest target markets is something we've developed for ourselves.
Okay, so what do you as director do exactly?
I've been working on a number of things. I've been communicating with the different business groups that have, as I said, pieces of the puzzle, trying to make people aware of what the other groups are doing, what things are working. I've worked on a training program for our product development people to understand emerging markets better. I've served on some working groups, written a lot, written some white papers, that kind of thing.
And so have you been doing this job for a long time?
No, not even a year yet. It's pretty new.
Was the job created specifically for you, or did you come up with the idea for the position?
I wrote my boss, Craig Mundy, who's one of our chief technology officers, a proposal to do this.
Oh, that's great. So you got to shape your own career by exactly.
I did, although when I think about the other things I've done at Microsoft, I started the second Microsoft Home. I've run several different prototyping groups. In all of them, I've been very concerned with innovation and how the company keeps moving. And in a lot of ways, I think of emerging markets with their constraints and the fact that they haven't been huge technology markets in the past as something that will pressure us and force us to innovate even more. So I see it as, in some ways, really in continuity with all of my previous concerns.
Mm-hmm. So what exactly did you get to do with the Microsoft Home? That sounds really interesting.
Oh, it was great fun. We had built the first demonstration home inside one of the office buildings that was on the campus before we bought it. And it was a very old building and was eventually torn down. So when the conference center was designed, we decided that that was the best spot for the new home. But the world had changed a lot just in the time between the first and the second. And also the number of people who wanted to come visit it had increased greatly. So we had both a technical innovation challenge and a facility challenge to meet. That was very rewarding and interesting work. A lot of people have come through that facility. It was always very nerve-wracking the first few times we would try out something new, but very, very rewarding.
That's great. What are some other things that you've been able to do at Microsoft?
Oh, I think, for example, of some of the education demonstrations I've worked on as being particularly rewarding. I'd say almost 8 years ago, we did a demonstration about a slate-like device that a student could carry everywhere that would have lots of educationally appropriate software, and that there would be a community of experts who would actually become involved in that kid's projects in education. And then about 5 years later, we did another demonstration, this time using tablet PCs, which by by then were in existence.
Mhm.
And so it's been tremendous to see these things that were just, a gleam in someone's eye get closer and closer to reality. Another favorite project of mine was working with wireless meshes, where we imagined not only could a personal computer have radio in it and wake up and find all the other computing devices in the vicinity that had radios in them, but that they could self-organize and form an unmanaged wireless network. So we tried to imagine not only what would that initial experience be like, but what kinds of applications would be interesting if you had that if you knew you had that kind of capability.
So you truly have worked in some of the cooler areas of Microsoft, it sounds like.
I think so. It's been an extraordinary opportunity to see what kinds of great features they're putting into the next version of the product, but also to work with lots of the researchers on what the capabilities farther out are going to be.
Right. So what are some things you like to do outside of work?
Outside of work?
If you can.
There is an outside of work. Oh, well, I've always loved the wilderness here in the Pacific Northwest, and I love to ski and hike and do those kinds of things. And I have a 14-year-old daughter who loves the PC in the living room, does most of her homework and all of her IM and blogging there. So
she's very sophisticated in her technologies, it sounds like, already blogging.
I don't know about sophisticated so much as to her, they're like air. They've just always been there. She can't imagine. I think back about the sitcoms that were on the air when I was a teenager, and one of the stock situations was nobody can get through on the phone line because the teenager is on the line all the time. Not a problem in our household. She's always on IM. The phone is always free.
Exactly.
So, I know my life is different than my mother's.
Sure, and there's not exactly an equivalent. That's great. So do you see yourself staying in the current position, a need for it for a year or two more? Or do you want to move on to something else in a year or so?
Well, I think there's plenty of need to figure out how to use our innovation in emerging markets. I don't see the need for that going away anytime soon. And a tremendous new challenge, I think, in terms of what's our relationship to innovation in these places, to the products that we already have, how do we rationalize not only the technical advances, but innovations in business models. There's a lot to do there.
So what would you say has been one of the highlights of your career?
I don't think I could confine it to one. There are so many things that come rushing at me when I think of high points. There was giving our wireless mesh demo to the FCC and the chairman of the FCC in their conference room in Washington, D.C. There was let's see, oh my, well, there was giving Martha Stewart a tour of the home.
How did that go?
Just fine. She was there with a number of other visitors for the CEO Summit. So certainly the opportunity to show our ideas to thoughtful and famous people. Some people who asked great questions, and people with different points of view is
Did you already place orders for things and say, I want that and that and
that? No, but I believe one of our people became her advisor on technology. So we at least had a small direct effect. Let me think. I'm thinking also of two different CEO summits where what my group did at the time, did was to develop something that we could actually hand the CEOs for the duration of the conference. And have them use it and understand what its implications were going to be for their businesses. So the first time that we tried to do something wireless, we used pocket PCs, and we had lots and lots of difficulties. I was pretty crestfallen at the time. I felt as if we had not succeeded in our mission. And I remember Craig writing a memo to us saying, or a piece of email saying, if you're going to live on the bleeding edge, sometimes there's going to be some blood. But the good point, the highlight of that story is that next year, I think we were much better prepared for managing risks and for getting all of our ducks in a row. And we wrote an application for the tablet. We used tablets that were hand assembled on the production line by managers because they hadn't been released yet, and the beta version of the tablet operating system, and we wrote our own small link instant messenger client. And during that summit, one of the attendees stood up and said, I think he was Turkish, Bill Gates, thank you for giving us handwriting. It was very rewarding.
Wow, that's great. Well, thank you so much for joining me today.
You're welcome.
Well, that brings us to the end of another episode of the .NET Show.
And stay tuned for the next episode on Windows Media Center.
And until then, we'll see you on the web.